thank you very much, everyone, for making it to this third keynote speech for the 2021 IEEE International Conference on Computing. We call it ICOCO 2021. And I'm very happy to have Associate Professor Dr. Jeffrey Tan, right? I would always know him and I will introduce him as the person behind RoboCup education at home, right? Met you, Jeffrey, probably like what, almost 2 years ago?
Yeah.
Yeah, and you introduced us how we can really bring robotics, you know, a more multidisciplinary area, right, that combines engineering, computer science, or even, right, like user behavior, psychology, and so on, under one hood. And I think that's probably the background. I wouldn't want to speak more. It's your keynote talk, but that is where I think many of us are interested. Can we really learn AI without computer science background? And with this introduction, I'm going to hand the time to you, Jeffrey, and yeah, take it away, yeah, for the keynote. Thank you.
Right. Thanks, Professor Lau, for the introduction. All right. So first of all, once again, I would like to thank IEEE Computer Science Malaysia chapter for the invite and also for hosting this session. Jeffrey, so it's very excited to be sharing some of my experience with you, especially just now I mentioned about this computer science background. So I got to know, like, for this conference, I think mainly the audience are from the computer science department. So I'm from the engineering department and from mechanical to AI and to robotics. So hopefully, like today, we can have some exchange regarding this AI learning or AI education. Right, let me start to briefly introduce myself. So I'm Jeffrey. I got my PhD in 2010 from University of Tokyo, Japan. And then I work in university as a researcher and also as an educator for almost, more than 10 years. And I moved to China in 2017 as an associate professor in Nankai University. And yeah, now I'm back to Malaysia. So I actually like one step from the campus, and now I'm working as a director for this AI robotics research center for my IDU group in Malaysia. And at the same time also, I'm not actually very far away from university, so I'm also currently a visiting professor in City University, Malaysia, right? So that is my profile. So you can see, like, I pretty much involved in R&D and also education in university. And at the same time, some related profile that I hold. For example, like I actually active in robotics competition, particularly in this RoboCup activity. So you can see, like, I actually serve as an organizing committee for several international and also local organization. So that is actually a bit related to my story after this. Right, so let's start. Okay, so first, I would like to briefly explain the background of this title and why I want to bring up this title in this keynote speech. So learning AI, artificial intelligence, without computer science background. Right, so today, actually not very technical presentation, I would say, but more like I would like to share with particularly the computer science community that how we can actually promote AI learning, right? And then why I put the keyword like without computer science background. Okay, one is very catchy, I think. Two is like, although you are the computer science community, please don't think that this topic is not relevant to you. Actually, I choose this topic to make sure that my talk will be relevant to the computer science community, particularly because I would like to promote the effort that currently I'm working on. And I would like to share this with the computer science community to actually work together to promote the AI or artificial intelligence education. Right, so that is actually the first part of my talk. Is like why I choose this topic is from my background, so from robotics research to AI education. So you can see, like, I actually started with robotics research, but today I'm actually fully focused on this AI education development. Right, so this is the first thing. And I'm very sure that what I'm doing now is very relevant to the computer science community, because like I really need to work with you guys to actually promote AI learning or AI education. And keep in mind that over here, when I talk about AI education, I actually mean not to say to foster, for example, like AI research or very state-to-the-art development and so on. But although that is very important, but what I'm currently doing is how to actually bring AI to the mass, how to let people without any technical background to learn AI, so that in future, everyone will know AI, even though they are not like computer science background and so on. So that is actually the key main point. Then the second part of my presentation, I'll focus more on sharing with you how actually I promote this way of learning, which is learning AI by building robots. So building robots, maybe you can see like, okay, it's something very technical and very complicated, but maybe you need to keep in mind that it actually in STEM and also like a very long history, for example, like Lego education, VEX education, and so on. We actually have a lot of like, you know, children robotics courses that learn how to build robots. So the point here is like, we are actually trying to learn AI by creating physical system, by creating real application and so on. Okay, so I'm making the keyword building robots, but in fact, it's actually learning AI by developing real AI application. Okay, so that is the main part. So later you will see like how the audience can actually, or the user can actually learn AI by doing the robots. Then the third part is reinvent and also rethink and also reinvent AI education. So this is the part that my work currently. Okay, so I actually like moved back to China, Malaysia like 2 years ago. So I started to focus most of my time in this AI education. Right, so this is actually just in the very beginning steps, but I would like to share with you this effort and also this, how to say, a new movement to actually make everyone rethink and also reinvent the AI education that we have today and also to bring forward for our future. Okay, so let's start with the first part of the presentation. So why I want to like share this topic? So from robotics research to AI education. So this is almost my 10 years experience that I'm going to share with you in a few slides. So first thing is like I would like to let you have a look on the robots that I built or we built or we talk about. So over here, we are talking about service robot. So it's actually a little bit different from the industrial robots arm that you see in the industry, but more focused on, not to say Roomba, like, you know, floor cleaning robots and so on, but this is actually one of the key point that I want to show. The robots that we are talking about today is mainly just in our life, okay, in our daily life, like this Roomba, which is exists like more than 20 years. It's already in like many households. It's a very common home appliance, you can say. So this is a very classic example of service robot that I can point to you. So when I talk about robot building, this is something in mind, right? And then for me, this kind of robot is basically AI plus robotics. And it is actually the real form or the practical form of AI in real world, in daily life. Okay, and why I choose this video is I want to see this robot is actually not just functioning as it's supposed, it's actually functioning more. For example, as compared to normal industrial robots, it is to pick and place for productivity. But Roomba at home, and you can see in this video, we are actually not talking about how clean it actually cleaned the floor, right? And or we are not actually mention anything about the productivities and so on, but more on the interaction between these robots and also normal human being, non-technical user, people who without any knowledge or background in computer science, right? So this kind of robot is what I'm going to talk about in this talk today, and how by building this kind of robots or the component, we can actually learn AI. So that is the key discussion of today. Okay, so actually over the years we have many, and for this kind of service robot, you may say like it's still very futuristic. It still very belongs to like the technology for tomorrow. But if you think again, especially during this pandemic, we actually have a lot of, for example, like remote control robots for in the hospital, right, to replace human nurses to take care of the COVID patients and so on, because that is actually to prevent the spread of the virus and so on. So it is actually slowly coming into our daily life. And you can see like, yeah, that day I still remember, like I went to one restaurant and actually I saw the, delivery robot to send the dishes and so on in the restaurant. So although you might say that this idea may be still in the future, but slowly we can see like this robot actually exists in our daily life. Yeah, very, very soon, like suddenly it become a lot. And Roomba has been exist in our household for more than 20 years and so on. So go down 10 years, 20 years, I will say this kind of robot will be slowly getting more and more. And now we talk about like autonomous car and so on, we have a lot. So AI, which is having the body in robots, is going to be living in our daily life world very soon. Okay, so just to give you some background why I started this development is because like when I graduated, I have my PhD. Then I start to think about what kind of research that I want to work on, or what kind of academic development that I want to work on. So I joined this, what we call the RoboCup at Home competition, which is an international robotics competition that promote service robot development. Okay, so the competition is, you can see, it's a very practical. So it have something like this. So a home environment. So we build robots to interact with real human, and then for some house tasks, for example, like clean the floor, serve you drinks, and so on. So this is the background. And as compared to many different kind of robotics competition, I would say this competition is very meaningful, especially for non-technical user or non-technical participant. Right, because everyone can understand, like building robots to serve the elderly at home and so on. Right, so it's very easy to explain, and also the technical challenge behind is very high and valuable. So it both have the complexity in scientific research and also have the practical value in real life. So that's why I promote this. So how to come to join this competition? I actually bring in my team from undergraduates, because that time I just graduated. I got my PhD, so I just start to like set up my labs and so on. So without much funding, and then my students are mainly undergraduate students. So we don't know much about this kind of robots. And my student actually they just start to learn like programming. We have no idea about like speech recognition, which is one part, very important part in AI and so on. So the key point that or the experience that I gained from this development is like, while I'm doing research for this through this competition, actually I need to think a lot of way how to educate my student in order for them to equip the related knowledge in order to join this competition. So actually, like more than half of my time is actually spent on doing education. And particularly in this case is AI education. So I need to show to my student how they can actually build robots that have AI or intelligent to interact with human, to do some tasks which is require AI technologies and so on. So I do a lot for this, and actually come up with a lot of a big system that can actually speed up the education process for my student particularly. So with that, you can see like over the year, my teams grow. Like this team Kamen Rider is my team for this competition. So many like first year, second year undergraduate students, they join because they see the attractiveness in robotics competition, particularly like, like in university, they learn a lot about all this technical stuff. But in this group, they actually enjoy and able to use this knowledge in real scenario, which is like solving the competition time. But of course, the winning and losing in the competition is one of the main point that attract them. But indirectly, they actually learn a lot, okay, from this training. Then also another things that I experienced in my previous university is like, I need to conduct this, what we call the robotic software engineering course. And in this course, which is very different from other course in, I belong to the AI College of Artificial Intelligence. Most of the courses are talking about, how to say, theoretical part, like how to do the calculation, how to do the modeling, how to do the simulations, and so on. So in the course in this course, because of the engineering part, I really focus on the practicability. So how to apply the knowledge or how to apply the theory in real world. So that actually also pushed me to create materials, and in a very short time, like one semester, how the student can really build this kind of AI robots. Okay, so these are all the past experience that actually like lead me to this AI education. Okay, so for the second part, I would like to show you by building this kind of robots, okay, what we can learn about AI. Or from the computer science community, you can see by building this robot, what are the things that the student can learn. Okay, so that will actually answer the question, how relevant is this AI learning to actual AI learning in computer science? Right, so this is my lab. So you can see mainly my students, they are from the engineering department, automation. They learn about automations and they just start to learn like programming and so on. So this is the background. So when they enter my labs, which is called the open robotics laboratory, so they are given this kind of robots, okay? And they're supposed to build application for service robot. For example, like how to make the robot speak to people, how to make them see the surrounding, recognize things in surrounding, and also how to do some tasks. For example, go to some place, find something, pick up something, and how to develop this kind of what we call the service robot application. Okay, so this is what happened in my lab. So what we do is actually not always very sophisticated. Like we don't always use very expensive robots and so on. We actually need to make it very cost effective because like I have a big group of students. So in order to prepare all the materials for them to start on the learning, I actually need to think of how to make this thing like available for everyone. So cost is one of the very big factor because like I need to prepare robots for everyone, every student. And then they have to hands-on. So I need to make sure that the cost is relatively affordable for a bigger ground, because like education is different from research. Research, we can like ask for a lot of research grant and so on, but for education, we need to really take care of each and every student. So I start to like find a lot of like, open source solutions, and also like just now I showed the Roomba. So I use the Roomba, which is something very related, similar product as the moving base of this robot. Okay, so Roomba, we can basically buy like one person one in order to like for them to learn how to make like autonomous navigation, map building, and so on. So we're actually extending from a very, how to say, popular platform called Tutorbot 2 and build it to become a service robot. Okay, so that also one of the very important knowledge or experience that I obtained is in order to make good AI education, we need cheaper hardware and also cheaper software, which means we need to use a lot of open source solutions and so on. So that actually is one of the very important things in education. Then by building this robot, you can actually see like it is actually comprised to several very distinctive research area in computer science. Okay, so for example, when we talk about the mobile platform, the robot leg, okay, mobile platform. So it actually let the student learn about autonomous navigation. So how to build a map, how to move around. So that relates to like, now we have the self-driving car and so on. So the student actually start to learn like how to build the map without actually knowing all the mathematics behind. Okay, because like the open source technology is very powerful. We can just take one library and then use the API and everything will just work. Okay, so the student actually learn how to do it without actually knowing all the underlayer theory. Very important. Okay, right. Later I'll explain more about this point. Then we have the visual perception, which is the eye. So I believe this is agreeable by the computer science department, which is a visual perception or computer vision related research. It's a very AI-based research. But in our case, they actually don't start with all the, reinforced learning or machine learning techniques and so on, but they straight away start with face recognition, because like that is what required in our competition. We need to recognize people in the surrounding in order to do some interactions and so on. And the robot need to recognize some object in the environment in order to do something. So they detect the things by color, by shapes, by a lot of things. So my students start to pick up all these things without actually learn what is actually machine learning. Okay, but indirectly, he and she actually start to pick up machine learning, then start to, like, even my student told me that, okay, we should use YOLO for this and this and this, which is, yeah, they are not from the computer science background, but by building this robot or building this kind of application, they actually start to learn AI, right? Then, of course, like object manipulation in robot arm and human-robot interaction by the mouth and the face, the ear. And then, of course, lastly, the brain, which is how to make the robot more intelligent, how to recognize the scene, the event, how to interact with people, and so on. So we need a lot of AI and machine learning techniques, and even computer science, cloud computing, and also big data. And there's one part I didn't put in here, which is the AI, the AR and VR, which I will show you some example later. Right, so start from the first one, we have this visual perception, which is the eye. So I think this one, everyone agree, right? So get the data and then how to process the data in order to get some understanding of the environment. So this is a very AI related problem. And then my student like get all these like color sensor data and also the depth sensor data, and then try to like detect the person in front, detect the objects and so on. Yeah. And yeah, without actually learning all the, for example, supervised learning or many other AI techniques, they're actually able to produce something like this, right? So they just like install the YOLO, try to learn how to train the model, and then yeah, open CV and stuff. So by building this application, my student actually able to learn AI without actually go from the bottom-up approach like in computer science. So that is actually good in my sense, but you may argue that they actually don't know anything. Like they are actually using a black box. Like using YOLO maybe is a black box. They just install the software and everything work magically. Yeah, you may say so, but please keep in mind that I'm actually focused on AI education. It's not about AI research. Okay, I will come back to this point after this. Okay, so just follow the flow first. Right, so in real application, in the competition, we actually have real-time face recognition, and also it works very well. Even like my students just undergraduate, and actually they are not into this AI research and so on. So they're able to learn. And also my research student, they're able to come out with master studies, papers for AI related, or those we are from the engineering department. All right, so navigation, just now I said about the autonomous driving, mapping, and so on. So how to optimize, for example, like the path planning, how to avoid obstacles. We use a lot of AI technology because like we need a lot of learning techniques in all this application. Okay, just to show you some part, for example, like this one, how to do the obstacle avoidance, how to create a map, and so on. Right. Then, of course, for the manipulation, the arm. So how to detect the object in front, and then how to do the planning for the arms to do the grabs and do the avoidance and all these things. We also use a lot of AI techniques in order to have real-time application or real-time operation. Okay, let's show you some video. With this, like, so this is not pre-programmed. The robot actually need to try to search for the object and try to grab it. Okay, right. Okay, then again, research paper on navigation and also on grabs. So how to find the, so this is actually very interesting topic that everyone will appreciate. We are actually building, we have Roomba that mop the floor, sweep the floor, but then after that, a few generation later, we have Roomba that can mop the floor. So can we, like in tomorrow or in future, we have a Roomba that can actually pick up objects from the floor and rearrange them. Okay, so it is the next generation of Roomba. We would like to build something like that. So it's something very similar to Roomba, but not just sweep and mop the floor, but actually can tidy up. For example, like you have children at home, so you have all the soft toy. Can we have a robot that can tidy up the place? Okay, so this is this topic. So one of my master students actually challenged this, and she actually tried to develop the robot able to do this kind of task. Right, then we have human-robot interaction. So this one, I think, is very familiar with even non-technical user we have, because like we have Google Speech, Google Home, Alexa at home, and then we have all the mobile phone will have like Apple will have Series and so on, that you can do like speech recognition and so on. I think this is a technology or AI application that very popular for everyone. So how to build this thing without actually learning through the technical building blocks below? We are using the top-down approach. So you can see this module also, we have this part that our student actually learns speech, human-robot interaction or speech recognition by using a lot of API that are available. So their focus is more on understanding how it works and also understanding how to apply and build new application, rather than they're being bogged down by all the theories and being bogged down all they start from like the HMM and so on. Before they know all those things, they cannot learn all this, right? So my message here is like we can see a lot of this kind of AI technique already very measured, and now it is the time we see how we can promote the education for the mass. Right. So lastly, is about this cloud computing, for example. So how we can make robot that learn and then use this knowledge for other robots. Okay, so we actually have robots that take images of bananas and apples around and then share this knowledge through the cloud, and so that other robots able to get this. So this is also a cloud-based learning projects that we involve in. For example, like this is one of the projects that previously have done. So we use VR, AR. Okay, this is a virtual reality to do the learning. Okay, so we use a simulator to simulate the human-robot interaction, and then we start to pick up the knowledge, and then we have a learning framework so that this knowledge can be shared by other robots. Okay, and also like talking about VR, so we have, because like we need to focus on human-robot interaction.
Down front.
Sorry, so
please go to find.
So over here, we have the system that actually communicate with real-world human in order for the robot to learn. So this is all about how to do the machine learning and in real time actually interact with real people to get the data of the interaction in order to learn how to make the knowledge or how to build up the knowledge database for the robots. So we have all sorts of things, and you can see like all this development actually make the student learn a lot of this AI techniques and so on. Right. Okay, so I come to the last part of my talk, which is the timing is just nice. So I have about like 15 minutes to go. Okay, so lastly, I would like to share this. So this is actually, I just started this movement, which is like I'm promoting the AI education in a practical way, which means we learn AI by building stuff, by focusing on building application. And with this way, I can see that the potential, for example, like if we can integrate this part into STEMs, for example, STEM, STEMs learnings and so on, we can actually promote AI education or AI learning in a bigger scale. Like for example, like no longer just limit to undergraduate or university student, but high school students and even like primary school students, they can start to learn AI. So this is currently what I'm doing. Okay, so I'm working through this initiative. So in 2015, I started this what we call the RoboCup at Home Education Initiative. So in this initiative, we actually promote or we come up with several ways to promote this development or this effort so that people can learn and more people can evolve, right? So we have the education challenge, which is a challenge that target for non-technical and also the team that join, they're actually novice. They never have any experience in building robots or learning AI, but they can join. Like it is open for non-technical person. Then also we open source our robot platform, which is the hardware part. So we want to create some hardware that make people easily start learning, because just like I say, the cost is a very important factor. So we try to find out some hardware that people can learn with everyday things. For example, like you can modify your Roomba in order to learn AI and so on. Then we have the open courseware, which is we focus on developing learning hardware, software, courseware, okay, particularly in courseware, to help people and also to promote this to educational institutions. For example, like university or school teachers, they can actually take our materials, open source materials, and start to promote AI learning. And lastly, of course, outreach program. So I went to many places for workshops, talks, and so on to show the demonstration of the robots and how the student can learn AI, even though without any basic or any technical background. All right, and this activity is supported by various academic institutions, and also we have companies that support us, as you can see the logo down there. And also, yeah, IEEE RAS also funded us some of our activities. Okay, so this is the big picture. So we try to create the ecosystem. So we have the content, or we have the event at the center, and we try to pull the crowd from or the stakeholder from different places. For example, like we have the competition, so we'll build up the competition community. So that will have student, university, and schools, and so on. Then we have the community that build on the hardware, on the research side. So we have the research community that work on the hardware and software development. Then also we have community that work on the courseware, which is from the academic institution. And also we collaborate this with the government and also industrial partners. Later I'll show you some pictures that we actually promote this kind of AI learning to a bigger scale. Right, so this is how we create the whole ecosystem. Okay, then throughout this education at home education development, we started in 2015 in Japan. Then slowly we expand to Italy, Canada, as you can see. Like, and in 2020, we actually have many events planned but delayed or actually cancelled. But we replaced with our online challenge that I will show you pictures after this. And our original collaborators. So you can see once we push out this idea that they can actually learn a lot of AI techniques by building this kind of simple robots, many teams, many education institutions from many places, they actually see the potential and they bring this model into their university, their school to start this AI education. So you can see like, yeah, these are all the names that involve. So we have outreach to all over the world. We have organized plenty of workshops, talks, demos, and challenges and exchange and so on. So many people. And yeah, I've been to many countries to promote this. So these are all the challenges, the competition throughout the whole the year. So from the national level, then we slowly go to regional level, and eventually we have an international level. For example, like the show is an international competition, the one in Sydney also. And you can see the people that involved from graduate student to undergraduate student, and slowly you can see like high school student actually involved as well. Yeah, so and also just now I mentioned a lot about like this open source hardware and so on. We actually recently, not to say recently, we collaborate with SoftBank for a few years and start to also promote for people that not building the robots but want to develop robot without touching the hardware. Okay, right. So this particularly for very young age student, because for very young age student, for example, like primary student, they don't have the skill set to build robot for the hardware and so on yet. But they have the skill set to develop software, like the computer science learning, but not really focus on the algorithm, but focus more on building the robots algorithm, right? So we also have this. You can see like they are very young. They are like primary school students. Okay, so. And because of the COVID, we have to do things online. So in 2020 and 2021, we have the online challenge. But yeah, although the COVID, yeah, our activities still go on. Right, then we have a lot of hands-on workshops in many places. Japan, I've conducted many workshops in Japan, then in Malaysia and Iran as well, many places. And our workshop actually collaborate with many companies. You can see like MassWork, Robotics, and Medias, and so on. Yeah, in Malaysia particularly, I actually went to much more, right? Even Sunway I also been to. This is how I learned, I know like Professor Lau. Yeah, to promote this and hopefully, because like this one, I think mainly is the engineering department. So hopefully today, anyone from the computer science department that interested in this, yeah, I would like to go to your place and show our system, do some introductory workshops and so on. So in China, the AI booming and also the effort to push AI is very high. And then we actually start to develop workshop for high school students. So this is one of the pilot study or pilot project in Macau, that the students start to learn AI, even as from like, middle school, like secondary year 1, they start to learn about YOLO. They actually develop YOLO application, and then they start to present their development in terms of like how they do the training and so on. I was so amazed with their development, and they do all this without actually undergo the computer science training at all. Right, and also like not just the open source robot, we have the Pepper robot. So this one work with SoftBank Robotics. It's a development workshops in university, and later we actually have training for adults as well. But I could not put the photo here. So slowly we gather all this knowledge, and then now we are developing this what we call the AI robotics curriculum for school. And then it is not just only for university, but for secondary and even as young for primary as well. So we will cover things like what is AI, how to build robots, how to do speech, computer vision, motions, and so on. Right. And also we seriously plan out the curriculum plan, like what they should learn in which year, down to the like details of like credit hour, what kind of assignment, labs. For example, like we design a series of labs. So we already have like 2 semesters of labs course structure available. So it is available to deploy in colleges, university, and now we also like try to have some pilot study with vocational school and training. And also we have primary school and secondary school collaborators to see how to implement AI education in their institution. Okay, so you may wonder what is the content look like, right? So we actually have open source resources. You can just go to our website. Later I'll post the link to you, or I will share my materials, don't worry, okay? you can actually experience, okay? And if you want like just have a look on how is it, you can go to our YouTube channel. You can see how the team actually built the robots and what kind of content they actually learn from this development. For example, we have this online classroom, which is open. So you can actually look at, go to the YouTube and look at our video. You can actually file the source code from our GitHub as well. We open source some of the source code, so you can actually download and run it with your hardware and so on. Okay, right. So I would like to save some time for Q&A. So I would like to conclude my talk now. So rethink and reinvent AI education. Okay, so over here, I have shared with you the history, how from robotics research faculty member, and eventually today I am full-time actually work on this AI education. And then currently I'm working with various institutions and so company, as you can see, like hardware company, software company, and also people, educational institution that develop courseware and so on. So I work with various parties to reinvent this, what we call the AI education. So I'll try to bring all these things together, and we are come out with a new framework, learning framework, a new system in order to promote AI education for general public, and particularly non-technical person, so that everyone in future, like even until children, they can start to learn AI. And AI learning is something that we need to plan for the whole span, from the primary, secondary, until like, yeah, university and so on. It's not like what currently we are doing, like focus on the university level or focus on STEMs and so on, but it's supposed to be planned in the whole span. So this is what I'm doing. And just a record that I've run this for like just 2 years. So we have pilot projects that runs more than 20 schools worldwide currently. So you can see like all this country, and particularly in China, they are pushing a lot. They put a lot of effort and also resources to actually promote this AI education. So my message today is if you feel like this is something that relevant to you and you're interested in this, particularly for the computer science community, I would like to say that this will actually enhance your courses, particularly in the practical application. So we actually build AI labs for this school. So they can build the robots, learn AI from the hardware, from the lab curriculum that we design and so on, and they learn AI from this approach. So hopefully this will generate some interest from the computer science community. And if you are interested, feel free to contact me, and we can discuss more how to actually deploy this, or share with you some knowledge, or even customize, design something for your department and so on. Right, so with that, I would like to close my presentation today, and I would like to open for Q&A. Thank you very much.
Thank you very much, Jeffrey. And I think from the interaction I see in the chat, everyone is very excited.
Okay.
Right. Thanks a lot. Very informative, very inspiring, the whole vision. And I believe this is just the beginning of the exciting journey that we can all undertake together. So first of all, let's go to the question and answer. So Professor Isaac Pogo asked for the free resources, but I think we have seen the URL. What I can inform is Jeffrey already given us the consent that we will also tidy up the recording and we'll publish on our Facebook group in the IEEE Computer Society Malaysia. And likely I will also put it in the YouTube channel. So at least you will find the keynote talk there. And then we can put also some of the links directly there so you can find them. Maybe I think that will be more efficient.
Don't worry, I will share my slide later on. I'll pass to the committee member, and they will like share the slides for you. And inside the slide, with all the links there.
And likely we'll probably put it on our conference website. So at least for a short while, you can still access those things there. And I think that will help everyone to get the information.
No problem.
Okay, so from Shilan, she wrote and said, can we say that for people now with background in computer science will be able to learn robotics easily without mechanical or electronic engineering background? The other way around from your topic. What do you think?
It is actually already like a realities ever since we have a mass-produced humanoid robots in like 2014. So I work with SoftBank. So they push out this a Pepper robot, which is a humanoid robots. So I didn't have much slide on it today, but actually I have another slide that mentioned this. So for computer science people, when you want to build robots, you have a lot of problem. I understand that because like in the RoboCup competition, we have people or teams from the computer science department. And then why you can see like in the mid of the slides, we actually start to collaborate with companies that develop robots. So that is actually to provide the platform. It's like we are building the computer for you so that you can run your software. Right, so you don't need to worry about the robots anymore, but you can build robots by just focusing on the algorithm, how to make it intelligent, because that is what we want to focus on in our development. We want to build intelligent robot for the future, because now hardware development really have some good foundation, I can say, but we lack of the intelligence, how to drive the robots to become more intelligent so that it can serve us better. So in order to have the computer science people come into our team, we need to make the hardware very robust and very easy to use for everyone. And that aligns to what because we need to bring the robot for children as well. So if the children able to do the development, I don't think have any problem for you guys in computer science department.
Yeah, I think this part we can testify because, like I said, we met and Jeffrey came and gave training to my colleagues and us. And we gotten also similar setup. And I think within a year, we have student staff working together. And it's really not just limited to engineers to work on it. Yeah, I would say that the topic, as I see it, very catchy, very smart to put it that way. But it's actually, we can easily replace computer science with engineering. The topic is still true. The whole thing is, if you allow me to share, is we try to put the entrance, right, the bar of entry lower, that let everyone learn the application first. I think that is a message I would definitely learn today. And then people who are interested in any of the area can continue on the depth if they want to, right?
Yes.
Do you agree, Jeffrey?
Yes, you're right. I think like you got the key point. So the key point is, okay, in a very brief term, is like AI education is more on training, not to say training, make everyone know about AI without actually become an AI expert. It's like all of us, we learn maths, but how many of us actually are mathematicians? But we learn maths, we use it every day. So AI will be the same down the road, maybe like 20 years or even like 10 years down the road.
Maybe closer, I believe.
Yeah, maybe closer.
Yeah.
So everyone need to learn AI. We should not put the bar very high that you need to learn all the supervised learning or whatever things in order for you to learn AI. We need to start learning by building some practical application. So that is my message today.
Yeah. Before I go to the next question, I just want to start this conversation. In your experience, Jeffrey, do you see people, even though they do not have the background, but right after getting the exposure, and I believe they'll get excited, especially young people, they started building the interest to go into the technical, the in-depth stuff, like YOLO, like mechanical engineering. Do you see those cases happening?
Actually, it happened in my student, actually. So my students are from engineering background. Okay, even some are from the mechanical background. And me, myself, is actually an example. Okay, my background is mechanical engineering. For my undergraduate, you can search from the history. But today I'm working mostly on the AI developments and so on. So my attention, and not to say I shift overly, but it is like AI actually is not isolated by its own. It is actually need to be integrated with a lot of different disciplinary, right, today. Like how to make electronics smarter, how to make mechanical systems smarter, and so on. We need to add AI. And even today, my friend from the biology department, they want to learn about AI, how to do the imaging and stuff. And even my friend talking about Bitcoin and also financial stuff, they also want to learn about AI because they want to use the intelligence for their sum analysis and so on. So everyone want to learn about AI, but we need to have materials or way to educate people without having them need to and sign up for the computer science courses.
Yeah, almost sometimes I tell you, you don't have to take a PhD now to learn AI, which is a good thing. So I hope this inspires everyone to start thinking, education may not need to start, to go technical in order to appreciate it. Maybe this is a way to get everyone interested. We often talk about younger people lost interest in STEM. I think one of my motivation learning about this, and working with Jeffrey is also to say, hey, can we use this to lower, the bar, and create more interest? And indirectly, we help to grow the STEM interest among young people, and then more will want to learn engineering and computer science.
Yes.
Okay, let's move to the other question. So it's an anonymous attendee say, regarding this top-down approach, what is your measure for offline environment like speech recognition without assistance or open source library, or maybe without connecting to a cloud-based intelligence? Maybe that's what the question.
Okay, I can answer this because like in our competition, we actually have very challenging internet connection. Always in competition, we are not like blessed with very like 5G connection or even like fiber connection and so on. So our robots have to react or whatever, have to work in the environment or in a condition without any internet connection or even network connection without. So everything have to run on board. So, and then our robots, we cannot have like a server like attached to it or things like that. So we have to optimize how our AI module so that it can run like offline, so that it can work on board in practical. So one thing I learned about competition is we have to make things very practical. And it is the same like building products. So it is very different from research, which is we have endless resources. We don't need to talk about bandwidth, latency, and so on. But in competition, we are not in that case. You need to face the reality. So that's why particularly when we do the workshop, we also like sometimes, for example, like I do my presentation in many like rural areas and so on, which is sometimes I only have my cell phone that can connect to the internet. So under these kind of things, we have to think of solution that can work without internet connection. And it works. For example, like speech recognition, we have in our module, if you have a look, we have the offline speech recognition and online speech recognition both.
Yep, I think we are now spoiled with the online libraries that we thought that's the only way. But I've used some offline ones, like even Firebase has some very nice SDK with offline model, and they work actually pretty good.
I see.
So I think these are a few things. Yes, fail safe. The person asked also mentioned, and I believe in the real world, I think that's the keyword. We must consider both options, and fail safe must be built into it. And again, students, I think in your experience, they must have found out that that's necessary, and they now will consider it. So we not only do research, we also try to bring closer to a real environment, right? And I think that is a very valuable learning experience.
Yeah,
right. Yeah. So let's move to the next question. It looks like the last one, if no more coming. Zing from Summer University asks, what's the collaboration model that you have between your current institution or your this RoboCup at home education with university and school? Can you elaborate a little bit more? Maybe this will invite more to come to you, which is a good thing.
Right. So just for your information, like just now I already mentioned in my profile that I'm no longer as a full-time faculty member in university, but I still stay relevant because I'm a visiting professor, and also I'm a advisor for several institutions as well. So now I'm in a very neutral position that I can work with industrial, commercial, and also academic, right? So I'm in the position that can do that. So now we have a few collaboration model. For example, in academic term, we can have research collaboration. Okay, so that is one thing that we can push forward the research. And then for me and university, there's another way is we can collaborate to develop courseware, course development. And I think that is very important for many places because this AI education or AI learning or AI courses is very new in anywhere in the world because they don't have a very systematic structure how to come up with AI courses, because like every different level, they have different requirements. For example, we can teach AI in computer science department. We can also teach AI in engineering department. We can teach in IT department, and even we can teach in biotech department, right? So we can have a collaboration model that we can co-develop the courseware. For example, for your university. For example, like your university, you have like computer science. So we teach a lot of theory, but we need some practical courses. For example, you need an AI lab. Okay, so one of the projects that I'm running on is how to assist a university or college to build up the labs so that they can have some lab module to let the student understand the concept in the theoretical concept in classroom. So for example, like you learn like your convolution, neural network, and so on. So how to use this thing in real world, right? So we design the labs and so on. So this one is by courseware development. And also commercial, also we work with companies. For example, a lot of companies, they have a lot of hardware technology, they have software, they have API, they have a library and so on. So we work together to see how to use their API or whatever hardware they develop. For example, like I actually work closely with two major hardware company. So how to use their system in order to facilitate or promote AI learning. So I work with various hardware and also software company for this as well. And also for training center, for example, like you are running a training center for like vocational, for example, for adults trainings and so on, which is if you want to train people to start some AI jobs in future, because like a lot of people, they have a computer science certificate, but they cannot find works that related to their studies. So because if you have theories but you don't know how to apply, it's very hard to get the jobs. So for us, we have the training to train so how you can relate back whatever that you learn in classroom and how you can apply this in real world. For example, if you want to work with a autonomous driving company, for example, so how you want to use your whatever that you learn in computer science and put in hardware. For example, like put in the car. So how to build a map, how to detect people and so on. So you need to know the technique. So we actually have this kind of training and we discuss, and this is how we collaborate. So feel free to discuss with me. I have my email, so my email is over there. Write to me, just give me your email and we can start talking. I can show you more. And also for all the university, colleges, and also school, feel free to contact me. I will give you like, not to say give, I am very much interested to do some talk, seminar, or some training, or some even workshops at your place to show you something like this. Because for me to come back to Malaysia, I really want to do this in Malaysia. And yeah, I really want to like go. And now hopefully COVID already like start to like reduce and I can go. So hopefully I can do like hardware demonstration like what I previously did in Sunway. I would like to resume this so that can show you how people can appreciate AI in a physical way.
Yeah, I think if there's interest, institutions, or different departments, faculty, do write to Jeffrey. The email is there. And if through the society, if you all feel, hey, we want events like that, maybe I think I will get in touch with you, Jeffrey, maybe from Computer Society. We can organize also workshop next year when things are even better, so that we try to promote this together. I believe still in the vision that the more people we can equip them with this knowledge, the excitement towards how technology can be so accessible. Previously, it would cost probably 3-4 times to get into this field, but today it has actually been a lot easier. And I think we just have to find ways, to collaborate. And you already mentioned there are so many options. Main thing, start the conversation and work step by step towards it. And personally, this doesn't represent anyone. Our relationship with Jeffrey, I can say he's very sincere, and it's really his passion, to promote AI learning, robotics, and making it accessible is something that I appreciate. I really admire his passion. So yeah, I'm now in a way promoting you, but I think it's worthwhile. It will really help us, especially Malaysia, Southeast Asia, to build talents that are exposed to such talent. Okay, I do see the last question here. We are already at 11:05, so I'll make that the last question. That's from Aditya Subhash. And say, can you share the slides?
Yeah, my email is always here.
Yes, correct. Yeah. So as I said earlier, as I conclude, the email is there. We will also publish the video later. So check out the conference website and also join the Facebook group. And later we will also publish a link that you can join the IEEE Computer Society Malaysia chapter Discord server so that you stay in the community. And when we get all these activities, and if you have requests, right, let us know so that we can then arrange activities that will benefit the society and the community. Okay, thank you very much.
Yeah, thanks a lot.
With this, Jeffrey, thank you for very engaging and informative presentation. I think many are already inspired and your mailbox will be bombed very soon. I think this is something we all can contribute, and hopefully we get to train more talented young people, you know, and yeah, start making transformation to our society. Yep. So thank you again on behalf of IEEE Society and also the conference organizer. Thank you for your keynote, and look forward for future collaboration then.
Right. Thanks for the hosting. Thanks, Professor Lau, and hope to communicate again, right?
Yes.
In the future, and we can collaborate for more activities together.